Okay, in section 1.7 inequalities, we're going to study how to solve linear inequalities and inequalities with absolute value. The reason why we're studying this is that sometimes it's interesting to talk about a variable in terms of what are the possible values that this variable may take. For example, if x is your age, then I can say that unless x is greater than or equal to 21, you know what happens then? You're allowed to drink. So until this doesn't happen, then you're not allowed to do that. If x is the speed at which you are driving, then your speed needs to be in parts of the highway less than 55 miles per hour, and if you go over that, then you'll get a ticket. You probably won't, but that's what they say. So we really don't have a particular value for x. You can go at 30 miles per hour and still don't get a ticket, or you can go at 40 and still don't get a ticket. So the solution, the values of x that satisfy this are infinitely many, rather than just having a unique one. Your speed should be this much, or your age should be this much. So this is pretty much the big idea about inequalities. So let's learn some properties. Whenever we're solving inequalities, we can add the same amount to the left and to the right of the inequality, and that would actually preserve the direction of the equality. For example, if I know that the number 2 is less than or equal to the number 10, if I decide to add 3 on both sides, then I know that the result on the left and on the right will still be true. 5 is less than or equal to 13. And the same is going to happen if I subtract a number. For example, if I subtract 6 from both sides, 5 minus 6 is negative 1, less than or equal 13 minus 6 is 7, and this is still true. So I'm just showing you with an example that these properties hold for the inequalities. Then it says, if you have a number that is positive, then you can multiply that number in both sides of the inequality sign, and then this still will be true. For example, if you know that 2 is less than or equal to 6, and this is true, not the equal sign but the less than, that's why this is read less than, or okay, one or the other. No, both of them are going to be true. So you know that the less part is true for 2 and 6. So if 2 is less than or equal to 6, and I multiply both sides by 3, then the result will be on the left side 6 and on the right side 18. So this is still true. 6 is less than or equal to 18. But it's important that you remember that it's a positive number, because what happens if I multiply by a negative number? If instead of 3 I multiply both sides by negative 3, then I have here negative 6, and in here I will have negative 18. And how do they compare? Negative 6 is closer to 0. If I remember the number line, negative 6 is here, negative 18 here. If I'm comparing two numbers, the bigger number is always the number to the right. Oh, sorry. Negative 18 here, negative 6 here. This is the number that is most to the right, so that's the bigger number. So negative 6 is bigger than or equal to negative 18. So what's going to happen is, and what we're going to learn, is that when I multiply by a negative number, the direction of the inequality changes. Rather than having a less than, it's going to become a greater than. For number 4, if that number is negative, less than 0, then the inequality changes direction. And this is what it says here. Reverses the direction of the inequality. Now for number 5, we have if A is a positive number and B is a positive number, and this is true, then when I take the reciprocal, when I take the reciprocal, then that's going to reverse the direction of the inequality. Let's look at this. 2 and 3, how do they compare? 2 is less than 3. I could write less than or equal to, it doesn't matter. Let me show you that with less than it also works. Then when I take the reciprocal here, and I take the reciprocal here, now remember that when you divide a pizza by 2 and when you divide a pizza by 3, the bigger slice will come out of dividing by 2. So this fraction is bigger than that one. So whenever we're taking reciprocals on both sides of the inequality, the sign of the inequality, the direction of the inequality is going to change. The same is going to happen if I have less than or equal to 1/2, greater than or equal to 1/5. Since we're going to be talking about variables, if I know that 2 is less than or equal to x, when I take the reciprocal, I know 1/2 would be greater than or equal to the reciprocal of x, and that's all it means. And then number 6, if I have 2 inequalities, then I can add those 2. So for example, if I have 2, I love number 2, 2 less than or equal to 6, and then I have 5 is less than or equal to 11, then I can add those 2 and have the left side gives me 7, the right side gives me 17, and this is still the sum of the left side and the sum of the right side would be the same. Notice how I have the same inequality. If I have 2 less than 6 and I have 8 greater than 4, I cannot add these 2 because these 2 are not matching. I'm going to have to rewrite one of them. If I know 8 is bigger than 4, that's the same as 4 less than 8, and then I can go ahead and add. This will be 6, this will be 14, and this will be true. So make sure that when you're adding inequalities, it has to have the inequality in the same direction. Okay, it says solve the inequality and sketch the solution set. We're going to talk about what's the meaning of this. But first, let's solve the inequality. Solving the inequality means I want to know what values of x make this inequality true. And I don't know that yet because I'm going to have to try x equals 1, x equals 2, and x equals 3, and so on, to be able to tell when 3x is less than 9x plus 4. So instead of doing that, because that will take us forever, I just want to solve this like if it was an equation, and then we're going to see how the result is going to be convenient to talk about what are the admissible values for x. So the same idea with the equation, I want to group the terms that have an x on it on the same side. In this case, on the same side of the less than. Now notice how I knew how to read this symbol without knowing which number is bigger, because I know that if you have something like this or you have something like that, then you know how to read it because you know what number is bigger, you see the numbers. But in an expression like this, you can't really tell which one is bigger. So let's just remember, if you put your left and your right hand side like this, like you're gonna dance something, your left hand has the less than symbol. Okay, left, less. So this matches with this symbol right here, so I'm gonna read that one as less than. And naturally the right one is gonna be matched with greater than, because that's the only thing that I can do. But I thought it was very clever to relate less than with the left hand. Okay, so let me subtract 9x from both sides, and I can do that because the property or the rule in the previous slide told me that I could do that. So I have my inequality, and I'm going to subtract 9x from both sides. So it cancels out from the right side of the inequality, and I have left 4. And on the left side of the inequality, I have 3x minus 9x, which I can combine into negative 6x. And I drop the inequality the way I see it. Now, if this was an equation, the next step that I should take is to divide by -6 on both sides. And that's exactly what I'm going to do here. However, whenever I multiply or divide by a negative number, I'm going to change the direction of the inequality. So I'm going to go ahead and divide both sides by -6. However, this less than will be changed into greater than. Now everything else is treated like an equation. These two cancel out, so I have x, and then I have -4/6, which is 2/3. So now the only thing that means is that x could be any number bigger than -2/3, and for every single number this is true. So let's try. Give me a number that is bigger than -2/3. Where is -2/3? If this is 0, this is 1, this is -1. -2/3 will be right here. So you can give me -1/3, you can give me 0, you can give me 1, you can give me 2, you can give me 3 or 4 or 5, and 3x will be always less than 9x plus 4. So the way to graph, this is what I'm going to do. Okay, so I just want to convince you of this fact, and then we'll go ahead and graph the solution set, or sketch the solution set. So this inequality says, I want to know for what x's 3x is less than 9x plus 4. So my calculator, you don't have to do this, I just want to show you. This is 3x, and the next one is 9x plus 4. So when I go to table, for example, 3x when x is 0 is worth 0, and 9x plus 4 is worth 4. So you notice that for x equals 0, 9x plus 4 is bigger than 3x. For x.5, 3x is worth 1.5, 9x plus 4 is worth 8.5. This is bigger. For x equals 1, 3x is worth 3. 9x plus 4 is worth 13. You see how this is bigger. And for every single x, 9x plus 4 is bigger than 3x. Every single one. Like, look, it gets even worse. This is 31. This is 9 when x is 3. So I'm going to use all these x's in my solution. Any of these x's will make this bigger than that. So in that sense, that's how we write x is bigger than -2/3. X can be any number bigger than -2/3, and for those numbers, 9x plus 4 will always be bigger than 3 times x. So how do we show that in a graph?